students, in this video we will understand what is 1-1 function. 1-1 function is also called as injective function. Watch the video completely. At the end, I will have a question for you. You can comment and let me know your answers. Okay. Now let us check the definition first. If a function f, the function is f from x to y, that is x is the domain set and y is the codomain set. Function f from x to y is defined to be 1-1 or injective if images of the elements of x under the function f are distinct. That means different elements of the domain set should have different images in the codomain set y. Very simple. No two elements of the domain set should have same image in the codomain set. Every element of the domain set should have a different image. No two elements of the domain set should have the same image in the codomain set. That is what is the definition of a 1-1 function. That means if x1, x2 are two different elements which belong to the domain set, then the image of x1 should not be equal to image of x2. That is what is the definition of 1-1 function. That we can understand in this way also. If at all f1 and x2 are equal, then the elements cannot be different. If the images are same, then their pre-images should be same. Only then it is a 1-1 function or injective function. I have few arrow diagram for you. We'll understand or we'll check whether this is a 1-1 function or not. No, the first arrow diagram, it is the function f1 from x to y. So if you check, 1 is mapped to a, 2 is mapped to b, 3 is mapped to d, 4 is mapped to c. Different elements of the domain set are mapped to different elements of the codomain set. So this is a 1-1 function. Next one, if you check, 1 is mapped to b, 2 is also mapped to b. That means 2 comma b and 1 comma b. Two elements of the domain set are mapped to same element. That means this is not 1-1 function. Such mapping is called Minivan function. That means more than one element of the domain set will have the same image. Such mapping is called Minivan mapping or Minivan function. If the function is 1-1, it cannot be Minivan. If the function is Minivan, then it is not 1-1. Next arrow diagram. Here if you check, again 1 is mapped to A, 2 is mapped to A. So here again it is not 1-1, it is Minivan function. More than one element of the domain set is mapped to same element of the codomain set. So this is not 1-1 mapping. Now fourth mapping, if the function f4, you check, different elements of the domain set are mapped to different elements of the codomain set. That means each element of the domain set has distinct image in codomain set. So this is a 1-1 function. Now I have a shortcut for you to check whether this is a 1-1 function or not. But for that you should know the graph of the function or you should know how to plot the graph. In that case, we can easily find out from the graph whether it is a 1-1 function or not. Let us understand this with examples. I have considered f of x is equal to x square. We all know that this is a parabola. Okay. Now, I have the graph of a parabola here. How do I check whether it is a 1-1 function or not? That is, we have to draw a line parallel to x-axis. A line parallel to x-axis should be drawn and we need to check in how many points the parallel line meets the curve. So if you check, in this case it meets at 2 points, that is B and C. We could have drawn a parallel line below x-axis, but we do not have our curve here. So I have drawn the parallel line above x-axis. So clearly we can understand that here it is not a 1-1 function. From the graph if you check, the point B is minus 2 comma 4 and point C is 2 comma 4. That means minus 2 is also mapped to 4 and 2 is also mapped to 4. Similarly, if you check, minus 1 and 1 are mapped to the same element, minus 3 and plus 3 are mapped to same element. So this is not a 1-1, this is a Minivan. mapping. Now let us check the next example. F of x is equal to x. Clearly we know this is y is equal to x, the identity function, correct? This is identity function. This is y is equal to x is a straight line passing through origin. Okay, now again I have drawn a line parallel to x-axis. However, you can draw the line below x-axis or above x-axis. I have drawn it above x-axis. We can see that this parallel line to x-axis is meeting the curve at only one point, that is at point C. So which is that point? It is meeting only at a point C. At only one point it is meeting. So 4, 4. So 4 is mapped to 4. 4 is not mapped to any other element. In this case, this is 1, 1 mapping. So identity function is a 1, 1 mapping. Now the next example, f of x is equal to x cube. This is the graph of y is equal to x cube. Here again I have drawn a line parallel to x-axis which is above x-axis. I could have drawn the line below x-axis also. In that case also it would have met the curve only at one point. It is meeting at a point only. The parallel line is meeting the curve at only one point, which is B. So again in this case it is 1, 1 mapping. This is again 1, 1 mapping. If you know the curve, you can easily find out whether it is 1, 1 function or not. I have an example here. Show that the function f from R to R is defined like this is 1, 1. We are understanding in this with the help of this sum how to show that the given function is 1, 1 or how to check whether the given function is 1, 1. So the first thing we should do is we'll take two elements. X1 and x2 always belong to the domain set R. Now we are making an assumption. What is that assumption? F of x1 is equal to f of x2. The assumption is the images of these two elements are equal. We are assuming that the images are same and we are checking whether those two elements are different or same. So now we apply this x1 and x2 to the given function. How is the function defined? It is 3x plus 7. So wherever you have x, we are writing x1. In this case, wherever we have x, we are writing x2. So this is 3x1 plus 7 and this is 3x2 plus 7. So it is 3x1 equal to 3x2. And if you divide the equation by 3, what we get is x1 is equal to x2. The meaning is if the images of x1 and x2 are same, the elements x1 and x2 are also same. They are not different elements. That is how we are checking whether 1, 1 function or not, or injective function or not. So if we assume that the images are same and we come across that the x1 is not equal to x2, then we will conclude that the given function is not 1, 1. So in this case, we assumed the images are same. Then we said if the images are same, the elements are also same. They are not two different elements. So we are concluding that this is 1, 1 function. Now the next example, f from R to R, f of x is equal to mod x is 1, 1 or not. We need to check that. See, we know the graph of the function modulus x. So if you check the graph, you see draw a line parallel to x-axis. It meets the curve at 2 points. That means it's a clear indication that it is not a 1, 1 function. So we just have to understand why it is not 1, 1. The negative numbers here and the positive numbers are mapped to same y, same element here. So you just look for a negative number. So I am considering -2 and 2. They belong to the domain set, that is set of real numbers. So if I check the images, f of -2, the function is defined as modulus of x. So I am writing mod of -2. Mod of -2 is 2 only. And you check f of 2. If f of 2, mod 2 is again 2. So we could understand that -2 and 2 both are mapped to 2 only. So clearly we can understand that this is not a 1, 1 function. Here we checked that the images are same, but they are not same elements, but -2 is not equal to +2. So this is not a 1, 1 function. this is not 1 1. Students understand here, we had to prove that this is a 1 1 function. We always have to prove in general, that is x1, x2, y, a, b, c. We have to take the elements in general and prove. But when you have to disprove something, we are in the second example, we are trying to disprove that this is a 1 1 function. When you are trying to disprove that this is a 1 1 function, you just give an example. Yes, this is one element, or these are two elements which contradict that the 1 1 nature of the function, then we can conclude that this is not a 1 1 function. So always understand, when you are proving something, always prove in general. That is, in general, you have to say, you cannot give one example and say this is 1 1, but you can always give an example and say this is not 1 1. So when you are proving something, it is always in general. When you are disproving something, just give an example and disprove. As I told you in the beginning of the video, I have a question for you. Is function f from R to R, f of x is equal to 3x, 1 1 or not? You just have to comment and let me know your answer.